Hello my dear students, welcome to the ASD physics classes. Hope so doing really great. Students, in this class we are going to solve the question of mechanical properties of solids. Which year question is there? NEET 2018 question is there. Okay, very important chapter. Chapter is small but still very important. Okay, because sometimes this kind of question used to come in exam. Okay, so let's see the question. Question is looking bigger, but the concept is the very simple concept is there. Na? Just focus on the question. Let's see. So two wires are made of the same material and have the same volume. The first wire has a cross-sectional area A and the second wire has cross-sectional area 3A. Okay, after that, if the length of the first wire is increased by delta L on applying a force F, how much force is needed to stretch the second wire by the same amount. Okay, so in this question number of data is given. Now, so what we'll do, one by one we'll decode the question and then we will go ahead here. So first thing here, how many wires are there? Two wires are there. Here I have drawn the two wires. After that, both the wires are made of the same material. So if the wires are made of the same material, what will be there? Their Young's modulus will be same. That means y1 equal to y2, or we can tell here y is constant. Okay, first thing we have got it. After that, same volume. Volume is also same. That means we can tell here, see please here, v1 is equal to v2. Is it? And this thing we can decode little bit here also. Okay, so let's take here for example here. This one is having cross-sectional area A. In the question even they told the first wire has cross-sectional area A and the second wire has cross-sectional area 3A. So here cross-sectional area A, I have written here A1 equal to, and this one here, this wire is having the cross-sectional area how much? 3A. Okay, let's take this length is L1. Okay, and this one is having length L2. This length I'm talking about here. Okay, this length. Okay, and this. Okay, now after that what will happen? V1 equal to V2. So V1 how much here? A1 L1. A1 L1 is equal to A2 L2. Is it? So area is given. So can we find out the length ratio also? So students, if we find out the length ratio for example, like L2 by L1. So from here, see please, L2 by L1 will be how much? A1 by A2. A1 how much? A. A2 how much? 3A. That means what we are getting here? Remember that this L2 by L1 we are getting 1 by 3. This we have to remember that. Very important. And from this one thing also we may consider this V1 by V2, that means V is constant. Okay. So from the volume we have got the two relations. One relation we have got this one by A1 L1 equal to A2 L2. Second one we have got V equal to constant. Okay. After that what is telling that here, say length of the first wire is increased by delta A. This wire increased by delta A. Then how much force is needed to stretch the second wire by the same amount? That means if here delta L is there, here also what is there? Same amount. Same amount means what will happen that here again? That means here we can tell delta L1 is equal to delta L2. That means what is constant? This delta L is also constant. That means you can see what are the things constant. See please, Young's modulus constant, volume constant, even delta L is also constant. And in the question what we have to calculate? We have to calculate the force. Now we have to find out the relation where we can get the force and the Young's modulus, area of cross section, length, all these things together. Okay, so for that what we have to do here, we have to remember one thing actually. See please, you know very well students, we know that you know the spring force formula, na? Because later in a basic you know that very well. The wire can behave as a spring of a spring constant how much? Ya by L. So here you know the formula F equal to Kx. Now very easy formula for the restoring force in a spring. So here what will happen that here, this K I can write here even Ya by L into X. What is the X? X is the elongation length, delta L. So now what we have to do, we have to convert into the volume. So how to convert into the volume? Volume we know very well, V equal to AL. That means what we'll do here? Here we will multiply with the L. Here also we will multiply with the L. Okay. So now what will happen that here we can write here. See please. This F equal to this Y into this A and this L together. is it? This one we will write here AL, and after that here we are writing delta L by L. And now what we can do here, this is the Y, what is the AL? Volume. This is delta L, and here 1 by L. So if you will see backside, what other things are constant, you will see very well. Even before also we have written what other things constant. Young's modulus constant, volume constant, even delta L is also constant here, is it? So what will happen that here this volume, Young's modulus, volume, delta L is constant. That means we can get here F is inversely proportional to L. Okay, we have got very simple relation. Now what will happen that here again we have to write the ratio here. So we can write F2 by F1 is equal to L1 by L2. Is it? We are going correct here. One thing here. See this L, how much here? L square. How much? L square. How much? L square. Here also square. Now let's go back side here. L2 by L1 how much? 1 by 3. That means L1 by L2 how much here? 3. So here it will come here 3. So hence we can get here F2 equal to 9 F1, and as the initial force is given F, that means we can write here F2 equal to 9 F. This much force is needed.